Okay, my name is Brian Bulo. I'm going to teach mathematics, and today we're going to look at functions. So functions. Okay. So what are we going to look at under functions? We are going to first of all look at the definitions, just an understanding of what functions are. From there, we are going to look at the notation. How do we present functions? How do we write functions? And then we're going to look at some initial simple calculation, okay, of involving functions. And then we need to go into composite functions as well, okay, which we'll define later. And then we have to look at inverse functions too, okay, so inverse functions as well. All right, so we're going to start, and this is what functions involve. We're going to start with the definition. All right, so what is a function? A function is really just a mapping, okay? So a function is a mapping. If you have a set of elements, say A and B, these elements can be mapped onto another set of elements, okay, using what we call a mapping. So there will be a mapping that maps this set A to this set B. These elements will be mapped onto elements there. But there is supposed to be a certain transformation that is used for us to get the resulting elements, okay? So A can be mapped to, say, C. Maybe it can also be mapped to another one called D as an element. A may be mapped to an element called E, and B may be mapped to other elements as well. So this mapping is as a result of the mapping of this set to this set is as a result of a transformation that we have in between here. So there's something we have to do to A to get these results, something we have to do to B to get that result, or if there's another result at all. Whatever we are getting from here is as a result of running a certain transformation on these elements that are in the first set. So this is a mapping this set of elements to that set of elements via or using a certain transformation. So what is a function? So a function is actually a mapping. The only thing about a function is that if these are the two elements, like it was at first, these are the two elements of a certain set A, then the next set B is only going to have one output. So A can only give one output. B will also just give one output. So there will be a one element in A that is giving one element in B. Okay, so there is one here and one here. And then we're going to call it a one-to-one function because it is giving us one and one. It's not one to many like it was at first, because we had an E here, we had an F, there were many other outputs from the same A and B. So we can have many outputs, that will be a mapping, but when we want it to be a function just like this one, then we're going to have one in the input and one for each in the output, one to one. All right, now let's look at the notation for functions. Okay, so the notation for functions is written as that. This is the notation we're going to look at, and there are many other notations that we can use, but we're going to look at this at first. We say this is f of x, x in brackets and f outside. We say function of x, which is f of x. Now this is the one that would define the actual transformation that is needed to transform A to C. Remember, these will be numbers. So number A will be transformed to become C. Number B will be transformed to become D. So this is what we will use to do that transformation. Let's say we have this transformation as 2x minus 1. Let's say this is what we do for every input to have the output. So let's say these numbers were actually 5 and say -7. What will be the output? So since we have 5 here, we'll put 5 here and get the answer. Then when we have -7, we'll put -7 here, -7 and get the answer. So let's start with f of 5, which will be 2 times 5 minus 1. So this is 2 times 5 will be 10 minus 1, which is 9. 9 becomes the result. So 9 is the answer when we put 5. Then we're going to put -7 as well. When it is its 10, we put -7 and then get the answer. So put -7 and see what result you're going to have. Okay? Thank you for today.